Now let us see the next topic, which is the inequalities. So we have to see the inequality, what the inequality means. Generally we have seen, so let us take some example. So the example is determine the set. Determine the set means find the elements, find value of x, find x satisfying the inequality. Determine the set and sketch it on a real line. Okay, so let us consider some set with some inequality. Suppose I have a set x, set A, with the elements, that means x is real number such that for x plus 5 is less equal 13. So we have to find the set. That means what are those elements such that for which this inequality hold, 4x plus 5 is less equal 3. So we have to simplify this inequality so that we can get the values of x which are real numbers that satisfy this equation. So we have to find real number x such that for all these real number x it should be satisfied, right? So consider x is real number such that it is satisfied, 4x plus 5 is less equal 13. So we have to simplify this inequality. So what we can do, by using the algebraic properties of real numbers, I can add minus 5 on both sides. So it is possible. So it becomes plus 5 minus 5. The addition of plus 5 and minus 5 will be 0. So it will be, and on the right side it will be 13 plus of minus 5, so it will be 8, right? So directly we have used the algebraic property of real number. Now this can be written as x is less equal to, therefore the set A. So real number x satisfying this inequality is nothing but real number x satisfying this condition. That means x should be less than or equal to 2. So the set A is collection of real number x such that for x plus 5 less equal 13. So it is nothing but collection of real number x such that x is less equal to. So can you imagine what the set can be? So suppose this is a real line, this is 0. So identification of 0 is important for any system. So what can be the numbers those are less equal to? So if it is 0, here somewhere it can be 1, suppose it is 2. So what I want, all the elements in the set, on the set are, that means set of real numbers, those real numbers which are less than or equal to 2. So I should have all the elements those are less than or equal to 2, right? So this is my set A which satisfy this inequality. Let us see other example. Let us consider set B. So it is also collection of real numbers satisfying some other condition. So the condition is the inequality x square is greater than, strictly greater than 3x plus 4. So solve this inequality and find the set B. That means find all the elements x from the real numbers that satisfy this inequality. So what we have to do? We have to find a real number x such that it should be satisfied, such that x square should be greater than 3x plus 4. So we consider variable x as a real number satisfying this inequality such that x square is greater than 3x plus 4. So simplify this inequality to get the simplified version of this condition. So what is x satisfying this condition? So we can simplify this by using the algebraic properties. So it can be written as x square minus 3x minus 4 is strictly greater than 0. Now I have a degree 2 polynomial on the left. So what we can do with this? So we can factor this polynomial. So what can be the factor? X minus 4 and x plus 1, right? So this can be the factors of this polynomial. So it is addition will be minus 3 and the multiplication will be minus 4. So x satisfy this condition means x should satisfy this condition. So it means what? So this is one real number x minus 4 and this is other real number x plus 1 and the product is greater than 0. That means product of two real numbers is positive. We know when the product of two real numbers is positive, either both the real numbers are positive or both the real numbers are negative, right? So there can be two cases. So product of these two real numbers, the first one is real number and the other one is real number and their product is strictly greater than 0. That means their product is positive, right? So the product is positive if both the two real numbers are positive or both the two real numbers are negative. So we can have two possibilities. So either x minus 4 is positive and x plus 1 is positive, right? We can have this as a one of the possibility, or we can have the other possibility. Maybe both real numbers can be positive or both real numbers can be negative. Then the product of two real numbers will be positive, right? And the other one is x plus 1 is also negative, right? So these are the two cases. The product of two real numbers can be positive if both the quantities are positive or both the quantities are negative. But what does it mean? So it means that x is greater than 4 and x is greater than minus 1. X is greater than 4 and x is greater than minus 1. Or what does it mean? X is less than 4 and x is less than minus 1. So what can be the meaning? It means that is x is greater than 4 and x is greater than minus 1. So the combinedly we can say that x is greater than 4 or x is less than 4 and x is less than minus 1. So combinedly I can say that x is less than minus 1, right? You can check it on real line. This is 0. The first condition say that x is greater than 4. Suppose this is 4 and x is greater than minus 1. X is greater than minus 1, that means x should lie between this region and x is greater than 4 means x should lie after 4, equal to 4, after 4. So combine of these two things will be what? X should be greater than 4. Similarly, for these two conditions, x is less than 4, that means x should lie between this part, and x is less than minus 1, if it is 0, suppose it is minus 1. X is less than 4, that means x should lie between this region, this part of the real line, and x is less than minus 1, that means x should lie between this region below minus 1. So the combine of these two things will be x is less than minus 1, right? So how can I write this? It means that x is greater than 4, so the set of real numbers will be, therefore the set of such real numbers will be, so it can be real number x such that x is greater than 4. And that of for this case also the set of real numbers can be, or real number x such that x is less than minus 1, right? Therefore our set B, which is collection of real number x such that it should satisfy this condition, this condition or inequality, x square greater than 3x plus 4. So it means what? It means either x is greater than 4 or x is less than minus 1. It means that real number x such that x is greater than 4 or x is less than minus 1. You can write the answer by this way, or you can write the two sets separately. That means real number x such that x is greater than 4, or that means union the other real numbers can be collection of real number x such that x is less than minus 1. So what can be this set on real line? Suppose this is a real line, this is 0, and how to sketch this set? Real number x such that x greater than 4, suppose 4 is somewhere here, and what the set is? All the real number x such that x is greater than 4. So I should have all the real numbers, those are greater than 4, right? 4 to infinity. What is the other set, or the other possibility of x satisfying this inequality is real number x such that x is less than minus 1. So if this is the minus 1, so I should have all the elements below minus 1. So it will be from minus infinity, all the elements from minus infinity to minus 1. So this is the sketch of the set B, right? All real numbers x satisfying this inequality. So let us go to next example. Let us consider next set C. So what is C? It is also collection of real numbers x such that it should satisfy this condition, right? I want to collect the real numbers x from set R, set of real numbers which satisfy this inequality or this condition. 1 should be less than x square and x square should be less than 4. So how to find? How to find? So we have to find real number x such that it should satisfy this condition, 1 less than x square less than 4. That means what? It should satisfy 1 is less than x square and x square is less than 4. So these are two conditions on this set, right? So it means we can simply write this problem as set C as collection of those real number R such that 1 is less than x square and x square is less than 4. Right, x square is less than 4. Okay, so we first find set C1, which is x, a real number such that 1 is less than, or else we can directly we can have the simplification of these two inequality. So let x is real number such that 1 is less than x square and x square is less than 4. Let us simplify this part first. Therefore 1 is less than x square means I can write it as x square minus 1. It should be greater than 0, right? That means I can, now this is polynomial of degree 2. This is polynomial of degree 2. So I can factor this polynomial as x minus 1 into x plus 1. Now it means that product of two quantity is positive. Product of two real quantities is positive. When the product of two real quantities is positive, so we can have two cases, either both the quantities are negative or both the quantities are positive. So it may happen that, therefore we can have two possibilities, either both the quantities are positive, both the quantities are positive, or we can have other possibility, both the quantities are negative. That means x minus 1 is negative and x plus 1 is also negative, right? We can have two possibilities. But what does it mean? It means x can be greater than 1, x can be greater than minus 1, or what does it mean? Maybe it can be x less than 1, and the second thing can be x less than minus 1. So what does it mean? X is greater than 1 and x is greater than minus 1. So suppose I have the real line, and what does it mean? X is greater than 1, so x lies in this part. Suppose it is 1, so x is greater than 1, that means x should lie above 1, and x greater than minus 1, that means x lies above minus 1, from minus 1 to infinity. So what will be the common part of the two conditions? So it will be x greater than 1. Therefore x greater than 1 is the common part of two conditions. Similarly for this part, x less than 1, that means x belongs to this part, minus infinity to 1, right? And the second thing, x less than minus 1, that means x lies in this part, from minus infinity to minus 1. So the common part is this part. So x is less than minus 1, right? Therefore what we get? We have real number x in R when x is greater than 1 and, or sorry, x is less than minus 1, right? This is for one condition when x is real number and satisfying half of the condition of set C. Now we have to see the second half condition. Now let x is real number such that x square is less than 4. Again I have this inequality x square minus 4. So I can write it as x square minus 4 strictly less than 0. Right? This is again degree 2 polynomial. So I can factor this polynomial x minus 2 into x plus 2 less than 0. Now it means product of two quantity. This is the first quantity and this is the second other quantity. And this is their product is less than 0. Product of two quantity is less than 0 means what? When the product of two quantities will be less than 0, if one of them is positive and one of them is negative. So again we can have two cases, therefore we can have two cases again. So the first case can be, suppose this thing is positive and this thing is negative. X minus 2 is positive and x plus 2 is negative. Or what can be the second choice? What can be the second case? In the first case this is positive, this is negative. In the second case it may happen that this is negative and this thing is positive. X minus 2 is negative and x plus 2 is positive. Right? Now simplify these two things. X greater than 2 and x less than minus 2. Or for this thing x less than 2 and x greater than minus 2. Try to check x greater than 2 and x less than minus 2. So does we have this kind of a real number which is greater than 2 and which is less than minus 2? Can we have a one real number which is greater than 2 and which is less than minus 2? We don't have, right? So don't exist such x for which x is greater than 2 and x is less than minus 2. It is not possible. So let us see on this side. What is it? X is less than 2 and x is greater than minus 2. It is 0, it is minus 2, it is plus 2. X is less than 2 and x is greater than minus 2. So x lies in this part. It is possible. So minus 2 is less than, x is less than 2. It is possible. So we have real number x such that minus 2 less than x less than 2. Therefore, the set C is real number x, collection of real number x such that 1 is less than x square less than 4. It means what? It means it collects all the elements of real number R such that 1 is less than x square and x square is less than 4. So what conditions we get? So we get then x is greater than 1, x is less than minus 1, and the other thing is this x lies between minus 2 and plus 2. Right? Therefore, complete the set. Therefore, geometrically, how you can show this part? If this is 0, how you can show x is greater than 1? This is 1. X is less than minus 1. This, and x lies between minus 2 and 2. This is minus 2, this is minus 1, this is 1, this is 2. So geometrically how you can show this? X lies between minus 2 and 2. X greater than 1, x less than 1, less than minus 1. So combinedly of these three things, what is it? X can be greater than 1, x can be less than minus 1. So The combined part will be this. Right? So let us see the next example. Let us have set D, which is collection of real numbers satisfying this condition. Again, simplify this inequality and describe the set D, and then that means find out what the elements of D can be, and then sketch the set D on a real line. So we have to find real number x such that it should satisfy this condition 1 by x less than x, right? Therefore consider a real number x such that it should satisfy this condition 1 upon x less than x. So simplify this thing. So how I can write this? I can write it as x minus 1 by x is greater than 0, right? X minus 1 by x is greater than 0. Simplify this thing. So I can write it as x square minus 1 upon x is positive, or I can write it as the factors in the numerator x minus 1, x plus 1 upon x is positive. Now it is ratio of two quantities, right? And it says that ratio of two quantities is positive when both numerator denominator are positive or both numerator and denominator are negative. Therefore we can have two cases. Both numerator and denominator can be positive. X square minus 1 is positive and x is positive. This can be one of the possibility, or the other possibility can be both are negative. Numerator is negative and denominator is also negative, right? So try to simplify this. Now this x square minus 1 means x minus 1, x plus 1 is positive and x is positive. So again this case can have two possibilities, right? So therefore this product is positive. That means both the quantities can be positive or both the quantities can be negative. So let us have both the possibilities. So x minus 1 is positive, x plus 1 is positive, and x is greater than 0. This is one possibility, and or the other possibility can be we left this part to solve later, right? And the other possibility can be both these quantity are negative, that's why the product is positive. X minus 1 is negative, x plus 1 is negative, and x is positive. So try to simplify these two things. It means that x is greater than 1, x is greater than minus 1, and x is greater than 0, or this says that x is less than 1, x is less than minus 1, and x is greater than 0. So what does it mean? X is greater than 1, x is greater than minus 1, and x is greater than 0. So on real line what we can have, x is greater than 1, it is 1, it is minus 1. X is greater than 1, that means x lies above 1. X is greater than minus 1 means x lies above minus 1 to infinity. X is greater than 0, that means x lies above 0 to infinity. right? So the common part is x is greater than 1, right? For this part, on the real line, x is greater than 1, that means x lies above this part 1. X is less than minus 1, that means x lies below minus 1. And x is greater than 0, that means x lies above 0, right? So what is common part to these three things? Nothing. Why? Because I don't have any real number which is at the same time it is greater than, sorry, it is not the thing. Sorry, let us do it again. What can be a real number x? X is less than 1, that means x lies in this region below 1. X is less than minus 1, so x lies below minus 1. And x is greater than 0, x lies in this part, right? What is common to these three things? Nothing. Because x is less than 1, x is less than minus 1, and x is greater than 0, nothing is common. So this case is not possible, right? So x greater than 1 is the only possibility. And for now, let us consider the other case. Suppose x square minus 1 is negative and x is negative. So what happens to this case? It means the product x minus 1 into x plus 1 is less than 0 and x is less than 0. So how to simplify this? So it says that the product of two things is less than 0. That means product of two things is negative. When it is negative, product of two things is negative. When it is negative, if one of them is positive and other one is negative. So what can be the choices? So we can have the choices. Therefore, x minus 1, first thing is negative and other thing is positive, right? Then we can have the product negative and this thing x less than 0. Or what the other possibility we can have? X minus 1 is positive and x plus 1 is negative and this thing x less than 0, right? So simplify both the possibilities. It means x is less than 1, x is greater than minus 1 and x is less than 0. For this, x is greater than 1, x is less than minus 1 and x is less than 0. So what can be a real number? In this case, x is less than 1, that means x lies below 1. X is greater than minus 1, that means x lies in this region, and x is less than 0, that means x lies in this region. So the common part is this. Therefore, x should be greater than minus 1 and less than 0, right? Or in this part, what a real number x can be? X is greater than 1, that means it lies above 1. X is less than minus 1, that means it lies below minus 1. And x is less than 0, that means x lies below 0. So what the common part is? It does not exist, right? Therefore, in the set D, real number x such that 1 upon x is less than x can be set. Which set? Real number R such that, real numbers from R such that it should satisfy what? From the two cases, one is x should be greater than 1 and or the second case for this it is invalid. In the second case we get minus 1 less than x less than 0. So geometrically what the set will represent, what are those real numbers on the real line? X is greater than 1, that means x that lies above 1, right, from 1 to infinity, or x lies between minus 1 to 0, from minus 1 to 0. So this is the geometrical sketch of set D, right? So in the next lecture we will see some other things.